Did the AI community cross the AGI threshold without realizing it? Imagine hitting the finish line in a race but being so distracted by your playlist that you don't even notice. That could be what just happened in the AI world. A groundbreaking new paper from MIT titled "The Surprising Effectiveness of Test Time Training for Abstract Reasoning" suggests we may be closer to achieving artificial general intelligence, AGI, than previously thought, and no one's pressing the emergency button just yet. This paper takes on one of the hardest AI benchmarks out there, ARC, Abstraction and Reasoning Corpus, which tests whether machines can reason beyond memorized data. If AI can now pass this test, we might have just crossed a critical line without even realizing it. Let's dive in. What is the ARC benchmark, and why is it so brutal? You've probably heard of popular AI benchmarks, like GPT-4's coding exams, or math competitions like GSM 8K. But ARC, created by Google engineer Francois Chollet, the mind behind Keras, is nothing like those tests. Most AI models, like ChatGPT or Bard, are expert memorizers. They study billions of internet pages, learning patterns, and regurgitating relevant information when prompted. But ARC was designed to break this system. Why is ARC different? ARC isn't about memorization. It's about something deeper. Abstract reasoning, the ability to think logically about completely new problems. It measures core knowledge, basic reasoning skills like recognizing patterns, counting objects, or understanding physical properties like object movement. Here's the catch. Every ARC task is unique. There's no way to study for the test because the puzzles are intentionally designed to be unlike anything on the internet. This makes ARC a pure test of intelligence, not a test of how much data a model has memorized. Let's break down how ARC works. Imagine a grid filled with colored shapes. Some shapes have empty spaces, while others don't. The task? Identify the hidden rule, like all holes should be filled with yellow. A human can spot this pattern in seconds. The holes get filled with yellow. But for an AI model, this task is like solving a puzzle in an alien language. It has no prior data to rely on and can't Google the answer. Out-of-distribution reasoning. This is where AI hits a major roadblock. Out-of-distribution reasoning means solving problems that fall outside of anything the AI has seen before. Most AI models can't handle this. They're built to predict based on known examples, not to reason creatively. If we ever want machines to operate autonomously in the real world, out-of-distribution reasoning is critical. This is exactly what the MIT researchers targeted with their latest study. So how did MIT researchers crack one of AI's hardest puzzles? The answer lies in something called test time training, a method that lets AI learn while it's working on the task. How test time training works. Typically, AI models learn during training and then use what they've learned when running inference, solving tasks. But test time training changes the game by allowing the AI model to adjust its internal settings while it's actively working on a problem. Think of it like cramming for a test during the test itself. The researchers took it even further by adding a process called hierarchical voting. They generated multiple guesses by transforming the input data, flipping it, rotating it, or modifying it slightly, and then picking the most consistent answer based on a voting system. This approach helped the AI make better decisions in a highly structured way. The result? A 61.9% accuracy score on ARC's public validation set, something that AI models have never come close to before. This score isn't just good, it rivals human-level performance. This achievement is a major milestone because ARC was explicitly designed to be AI-proof. The fact that MIT's model performed so well suggests we might be closer to AGI than we thought. Are we the frog in boiling water? Some AI experts are sounding the alarm, comparing humanity's current situation to the frog in boiling water analogy. If you put a frog in boiling water, it jumps out immediately. But if you heat the water slowly, the frog won't notice until it's too late. Similarly, AI might be advancing so gradually that we're failing to notice when it surpasses key milestones, like passing the ARC test. Did we just cross the AGI line without even realizing it? Is search the key to AGI? The deeper insight here might be that search algorithms are the key to unlocking AGI. Consider AlphaGo, the AI that famously beat a human Go champion. In one pivotal match, AlphaGo made a bizarre, unexpected move that stunned its developers. They thought it was a bug until the move turned out to be brilliant. Why? Because AlphaGo searches for answers, evaluating millions of potential moves in real time. The same concept applies to ARC. By searching through multiple possible solutions during test time, MIT's model didn't just regurgitate memorized facts. It threw its way to the answer. Humans versus AI, smarter search, wins. The next big challenge? Search efficiency. Right now, AI models like AlphaZero evaluate millions of possibilities per second in games like chess. Humans, meanwhile, only consider a handful of moves, but still win. Why? Because humans search smarter, not harder. If AI can learn to search more efficiently, it could close the gap between machine-like pattern recognition and human-like intuition. This is where future AI research will likely focus. Have we reached AGI? Not quite. So, have we stumbled into AGI without realizing it? Not exactly, but we're closer than ever. OpenAI's. Sam Altman has hinted that the roadmap to AGI is becoming clearer. In fact, OpenAI's models already perform better when given more thinking time, suggesting that enhanced search techniques could be the missing piece. MIT's breakthrough shows that test-time TRA.inning and search-based reasoning might be the secret ingredients we've been waiting for. The question is, how long until these techniques scale to even bigger models? Did MIT just move us one step closer to AGI, or is this another flashy AI achievement that'll fade away? We'd love to hear your thoughts in the comments below.